The last section in the geometry unit is over volume. So we've dealt with perimeter, distance around. We've dealt with area, which is the surface, and now we're going to look at calculating volume. And if you will look, volume formulas are down here, okay? And so, right now, don't worry about this last formula, okay? That was from previous, so we're just using all of this up here. Okay, so here's your volume formulas. All right, so what is volume? Volume is the amount of space in a figure. The labeling of volume is in cube units, okay? So, I don't know if you can see this. I have my water bottle with me, okay? So this is my water bottle. And so the volume would be the space inside. So when I fill this up with water, it's filling up the volume, okay? And the reason it's in cube units is because if you had a whole bunch of little cubes, you'd want to know how many cubes could fit in that space, okay? All right, so here is the formula. All right, so first we're going to look at rectangle and or square. It's the same. And here is that formula. And it is length times width times height. Okay, so I have a square, but again, it's the same formula if it was a rectangle. So length would be here to here, which I'm going to tell you is 5 inches. Oh, I'm going to do that in blue. All right, width would be from here to here, 5 inches, and then height would be how tall it is, which would be 5 inches. So, when I go to find the volume, sorry, I got water on my paper, it is length times width times height, which is 125. Now, the key is on the labeling because it's in cube units. So that means I'm doing inches cubed. Labeling is very, very important. So that way you know if we were dealing with perimeter, it would be just inches. If we were dealing with area, it would be inches squared. Anytime you're doing volume, it's inches cubed. Okay, the next formula is a cylinder. And a cylinder is like a soda pop can. And that formula is pi, which again, we're going to use 3.14, times radius squared times height. Okay, so over here we have a cylinder. Suppose they told you that we have 8 centimeters here. And then this was given as 6 centimeters. Okay, so you have to pay attention. Did they give me diameter or did they give me radius? Since they gave me all the way across, they gave me diameter is 6 centimeters. I need the radius for my formula, which is half of that, so my radius is 3. And height is how tall it is. So my height is 8. So now I'm going to apply this formula. Volume is pi, and WebAssign uses 3.14, so I'm going to as well, times radius squared. Radius is 3. Don't forget to square it. Times height is 8. Okay, let's look at how we put this into our calculator. No, sorry, let me do a better job of that. Okay, so 3.14 times 3, and I'm going to push the x squared button, times 8, enter, 226.08. So 226.08, and we're talking about centimeters. Now, so many times students will leave this as centimeters. Remember, perimeter is centimeters, area is centimeters squared, volume is always centimeters cubed, because we're wanting to know how many little cubes could we put into this to fill the space. All right. The next one is a sphere, and that's basically like a basketball, a baseball, it's a soccer ball, this volleyball, the space inside of it. Here is that formula. It is 4/3 times pi times radius cubed. So the only thing we need is the radius, so let's say that that was given as 3 inches. So they gave me the radius, not the diameter. So radius is 3. I don't need the diameter for this, so I'm good. Okay, so volume equals 4/3 times 3.14 times radius cubed. Okay, I'm going to have to show you how to put a cubed in here. Okay, so we know how to put in a fraction times 3.14, times. Okay, I'm going to put in the 3. Now there's not a cubed button. When we enter squared, we just hit this one. But if I need an exponent other than 2, I push this up arrow and I put in 3. Now notice how, oh, you can't see it, sorry. The up arrow, I push the up arrow, so then I put in the 3. Now notice how the cursor is still up in the exponent. So I'm going to hit the right arrow and it'll bring it down, then I hit enter. So I get 113.04. And again, don't give me just inches. Inches is perimeter, inches squared would be area, volume is inches cubed. All right, so that is for a sphere. All right. We're going to do several application problems now. So I'm going to try to draw these. Hopefully I can draw them okay. So I need to draw a rectangular solid. Okay, so draw rectangle, and then I'm going to go here, here, here. Okay, close enough. You get the idea. Kind of hard to draw three-dimensional. Okay, it has a length of 4 feet, a width of 2.5 feet, and a height of 2 feet. Should have made it a little bit taller, but I'm going to go with the numbers given. Okay, so what we have to pay attention to is this is a rectangle and it's asking me to find the volume. So volume rectangle, I'm going to use this formula right here. So volume equals length times width times height. So length is 4, width is 2.5, height is 2. So 4 times 2.5 times 2 is 20, and my units are feet, and because we're dealing with volume, it's feet cubed. All right. It's asking for the volume of a cylinder. All right, so I'm going to try to draw a cylinder. All right, there's my cylinder. Has a radius, so this is a radius, so it means from the center to the edge of 10 centimeters, and a height of 45 centimeters. And so I go back to volume of cylinder. Volume of cylinder, I'm going to use this formula here. volume equals pi times r squared times h. And we are using 3.14 as pi. R is what they gave me, so I'm going to use 10. And it tells me to square it. And my height is 45. So 3.14 times 10 squared times 45, I get 14,130. We're dealing with centimeters, and because it's volume, it is cubed. All right? Volume of a sphere, which is like a circle. So the volume of a sphere, we're going to use this formula right here. All right, let's see if I can, these are hard to draw. Okay, I'm going to give it my best shot. All right, they give me the diameter. So in this circle, the diameter is 14 inches. Okay, so the formula is 4/3 times pi times radius cubed. Okay, we need radius. Notice that they gave us diameter, which is 14. But by now we should know that the radius is half of that. So my radius is 7. So I had to find this first. So it would be 4/3 times pi, we're using 3.14, times radius we found to be 7, and then we're going to cube that. All right, so fraction 4/3 times 3.14 times 7, and then to get cubed, you do this up arrow, 3, and then to get out of the exponent, you right arrow over and hit enter. Oh, looks like 6 repeats, but sometimes I think, if I remember correctly, they'll have you round to the nearest hundredth, which is 2 decimal places, so pay attention on WebAssign. So we're going to go 2 decimal places, which means bump that up to a 3. So it's going to be 1,436.03. We're talking about inches, and because it's volume, it's cubed. So what we did is we rounded to the nearest hundredth. So we rounded to the nearest hundredth, which is 2-place accuracy, just for a refresher on rounding. You'll have to pay attention to WebAssign. I don't remember what it asks. Okay, so application, we could be using a rectangle, a square, a cylinder, or a sphere, any of those. Okay. So this is a fuel tank. In a booster rocket is a cylinder 10 feet in diameter. All right, so diameter would be all the way across. So that's 10 feet. And 52 feet in height. That's huge, but for a rocket, it's going to have to be huge, okay? So a fuel tank, it tells me that it is a cylinder. And you put fuel in it, so we know we're finding volume. So cylinder volume, we're going to use this formula right here. So the volume will be pi times r squared times h. Okay, what did they give me? They gave me diameter is 10. So I need radius, which is half of that, which is 5. And of course, 52 is my height. So we're going to use 3.14 times, we found the radius to be 5. We'll square that, and we know it's 52 feet in height. Sorry, I'm trying to get where you can see it. Okay, 3.14 times 5 squared times 52. I get 4,082. We're talking about feet, and because it's volume, I know it's cubed. Okay? All right. Now, this is an auditorium. Let me see if I can draw this, and then we're going to kind of break it into parts. Okay, so this is an auditorium. An architect is designing the heating system for an auditorium and needs to know the volume of the full structure. Find the volume of the auditorium. It tells me that the length is 125 feet. The width is 94 feet. And the height is 32 feet. Okay, now, here's what you've got to pay attention to, okay? Because there's two parts to this, all right? So if I got rid of the ceiling, then I have a rectangle, okay? So I'm going to draw just the rectangle. This is without, whoops, sorry about that. This is without the dome on the top, so just the rectangle, okay? So we know this is 94 feet, we know this is 125 feet, and we know this is 32 feet. All right? So I can find the volume of the rectangular part. And we know that is length times width times height, which would be 125 times 94 times 32. So that's 376,000 feet cubed. Okay, that's the rectangle. So that's that part of the building. Okay. So the next part is a little bit more difficult to visualize. So now we need this part. So what is that? Well, it's not a circle, it's not a rectangle or a square. So it has to be a cylinder, like a soda can, but it's half a soda can, okay? So I'm going to pretend like we're cutting that roof off, which is half of a cylinder, and I'm going to draw it down here. Okay, now notice I did not draw this part because I don't have a full cylinder. Okay, so in essence, this side right here is this side right here. Okay, so I look up here. Can I tell how far it is from here to here? Yeah, that's part of this rectangle. So if from here to here is 125, so must this be. So I'm going to do 125 feet. Then I go, okay, from here to here is the same thing as this part, which is, if from here to here is 94 feet, then so must this be. So 94 feet. So in essence, we found that the diameter is 94, okay? All right, so now what we're going to do is we're going to find the volume of the half cylinder. Now, this is where you need to be careful. This is the formula for a complete cylinder, but we're doing half of that. So I'm going to do half times pi times r squared times h. Now notice we need the radius, not the diameter. So to find the radius, it is just half of 94. So if you would go to your calculator and do half of 94, you are going to get 47. So now I have 1/2, because we have just half of a cylinder. Pi is 3.14. Radius is 47 squared. And the height is how tall it is, which is 125. So 1/2 times 3.14 times 47 squared times 125. So we get 433,516.25. We're talking about feet and it's volume, so it's cubed. All right, now we're not done because we need the whole auditorium. We have found the base, or the rectangular part of the auditorium, the half cylinder of the auditorium. So to find the total for the whole auditorium, you're going to take that from the rectangle, 376,000, plus that of the cylinder, 433,516.25, and you're going to add them. So this is a lot of volume. So add those in your calculator and you should get 809,516.25 feet cubed. So that's your final answer. So you now have a WebAssign assignment over volume.